Hi, I'm Herb Gross, and welcome to lecture number 13 in Gateways to Algebra, where today, to make sure we're all on the same page, we'll have a review lesson just to make sure that everybody understands just what approach we're using. We're trying to show that there's a very strong relationship between arithmetic and algebra, and that in fact, they're just different sides of the same coin. In fact, I think this is good to focus in on, and that is that formulas are recipes that tell us how to compute one quantity once we know the value of other quantities. See, the formula relates one or more quantities in a way that we can measure. In other words, we don't just say something is happening faster and faster or something is getting bigger and bigger. We tell specifically in terms of a recipe just what's happening. For example, suppose we wanted to talk about a way of describing how feet and inches are related. You see, what we might do is something like this. We might say to a person, start with the number of feet, multiply by 12, and the answer is the number of inches. You see, we don't just tell a person that there's going to be more inches than feet. We tell them precisely how it's going to happen. Now, up to here, I think everything is simple. If you've never heard of algebra, and you can read, I think this tells you exactly what to do. The thing we notice is that this takes quite a while to write. So what we do is we say, okay, since the word feet starts with the letter F, let's abbreviate the step start with the number of feet simply by writing down the letter F. And multiply by 12, all we need to do is put a times sign and a 12 in there. And then to say the answer is, we just put down an equal sign. And since inches begins with an I, we simply let I stand for inches. And so what we have is F times 12 equals I. And this one little sentence, see, let's look at that. This one little formula takes the place of writing these three statements over here. Now we abbreviate even further. Since the times sign looks like the letter X, and we don't want to cause confusion, we leave out the X and just put the letter and the number next to each other. And since we're usually used to saying things like 12 apples rather than apples 12, we put the numerical adjective in front. So instead of writing F times 12, we write 12F. And then again, for a convention that doesn't really matter all that much, the answer part is usually written all by itself, and we start with that. In other words, the traditional way of summarizing, start with the number of feet, multiply by 12, and the answer is the number of inches, is to simply write I equals 12F. And then later on, to emphasize the fact that this didn't have to be feet and inches, basically what we do is we let the answer, which we call the output, be denoted by the letter Y, and the input, which is the number we started with, we denote that by the number X. For example, when we write Y equals 12X, for example, X could be the number of years, and Y could be the number of months. In other words, the same way that you convert feet to inches, you also convert years to months. So there can be a whole bunch of things this way. Sometimes the relationship gets a little bit more complicated. For example, instead of having Y equals 12X, we might have something like Y equals 12X plus 5. Now, where might we use something like that? Well, for example, suppose we want to know how many inches there are in, say, 2 feet, 5 inches. In other words, you'd want to convert what? The number of feet to inches, and then add on the remainder part, the 5 inches. And so what you might write is what? See, when you don't see the words, what you do is you look for the letter that's scrambled in with the numbers. In this case, that's the X. We use the parentheses as grouping symbols. Whatever is inside the parentheses is done first. So the way you read this is start with X, multiply by 12, and whatever the answer is, add 5 onto that. So if we had 2 feet, 2 times 12 is 24, plus the 5 you add on is 29. So 2 feet, 5 inches would be the same as 29 inches. Now, by the way, the reason that we use the parentheses is notice that without the parentheses, just writing 12x plus 5 this way, notice that if you start with the x, 2 things are happening at once. If you look at here, the x is being multiplied by the 12 if you look at it this way, but also 5 is being added onto this. It makes a difference whether first you add the 5 and then you multiply by 12, or vice versa. So to emphasize that we want you to multiply by the 12 first, we put this in parentheses. So for example, if I wanted you to add the 5 first and then multiply by 12, I would say what? Start with x. See, there's the letter by mixed in with the numbers. It's inside the parentheses, so we treat that as one number. What do we do next? We add the 5. Now what do we do next? The 12 is multiplying this, so we then say what? Multiply by 12. So in other words, if the input is 2, if we start with 2 feet, now we say what? 2 plus 5 is 7. 7 times 12 is 84. You see, and be very, very careful here. For example, one of the reasons that we study the rules of arithmetic is when you have 12 multiplying x plus 5. Notice that the 12 is multiplying everything in the parentheses, because that's one number. So the 12 has to multiply what? Both the x and the 5. So when you have 12 times x plus 5 in parentheses, the 12 multiplies the x to give you 12x. The 12 also multiplies the 5 to give you the 60. So in other words, this 5 over here is deceptive, because it's being multiplied by the 12 means that this is going to be a 60 over here. That's a very common mistake that people make. What they'll say is they'll look at something like this and they'll say, oh, let's see, we want to solve this equation. Since 5 is being added, let's subtract 5 from here and let's subtract 5 from here. The problem with that is that whereas this looks like a 5, it's really a 60. And that's the thing I want you to pay attention to. In other words, let's take a look at it from this point of view. Let me just get another. See, what's wrong with this picture? In other words, we have 12 times x plus 5. We say, okay, since the 5 is being added to the x, we want to get rid of it by subtracting it. So let's subtract 5 from both sides. We subtract 5 from this side. We subtract 5 from this side. Now we're left with 12x equals 79. But this is obviously something that isn't going to work. This has to be a whole number type of thing. You see, the most traditional way to solve this problem is to say, look, since the last thing that was being done was multiplying by 12, the first thing we're going to do is undo multiplying by 12. So what we're going to really do is what? Divide both sides by 12. If we divide by 12 on this side and 12 by this side, the 12 comes out over here. We're left with x plus 5. Divide the 84 by 12, that leaves us with 7. Now if x plus 5 equals 7, we can subtract the 5 from both sides, and x would equal 2. Now, you see, what happened over here was that when we said subtract the 5, what we should have done was multiply this out first, if you want to do it this way. See, it's 12x plus 60 equals 84. Now you see what's happening is what? First, the x is being multiplied by the 12, so we can't touch that yet because it's inside the parentheses. We first have to get rid of the 60, which is guarding the parentheses. To get rid of adding 60, we subtract 60. If we subtract 60 from one side, we also have to subtract 60 from the other side. And so what we wind up with is what? 12x equals 24. Now we can divide both sides by 12 and get that x is 2. You see, the reason for studying all these rules of the game is that just because something looks right doesn't mean that it is right. And what we have to do is what? Learn how to read the algebraic statement in plain English and then just use what we call reverse arithmetic to solve the problem. And what makes algebra look tougher is that sometimes we have more than just 1 or 2 steps in the problem. Sometimes the recipe is more than just multiply by 12 or multiply by 12 and add 5. Sometimes what you see is a real eyesore if you're afraid of the language. See, for example, let's look at something like this. Now let's just read. Look how complicated that statement looks. See, it's one sentence, isn't it? Now, how do we agree to do this? You start with the variable, the x. Now, it's inside the parentheses, so the first thing we're going to do is what? Add 2. Then what's the next thing we're going to do? The parentheses is being multiplied by the 3. Remember, we also agree that when we leave out grouping symbols, whenever multiplication and addition appear in the same problem, we always agree to do the multiplication first. So the way we read this is what? Start with x, add 2, then we multiply by 3. We're still inside the brackets, so we do what? Add 4 next. Now what's happening? The brackets are being multiplied by 2. We're also adding 5. We multiply before we add, so we now take whatever is in the brackets, multiply that by 2, add 5, and then finally you multiply by 4 because the 4 is multiplying everything that's within the braces. So in other words, if we break this down step by step, it says what? Start with x, add 2, multiply by 3, add 4, multiply by 2, add 5, and multiply by 4. Now you see, as long as these steps are written out, you don't need all of this. The beauty is that this one statement with the grouping symbols, once we understand it, takes the place of doing all this writing. Now, the way the game of algebra is played, we simplify these steps using the rules of the game as we go along. In other words, if we start with x and add 2, that gives us what? X plus 2. Now it says multiply by 3. Well, what's being multiplied by 3? The entire x plus 2. So by a distributive property, the 3 has to multiply the x. The 3 also has to multiply the 2. That gives us 3x plus 6. The next step says what? Add 4. So we're taking this amount over here, adding 4 onto it. By the associative property, we can regroup any way we want. We can add the 6 and the 4 to get 10. So now we're at what? 3x plus 10 after we add the 4. By the way, we can't add the 3 and the 10 because the 3 is modifying x and the 10 isn't. See, we can only add when they modify the same noun. We next multiply by 2. Now what's being multiplied by 2 now? It's the 3x plus 10. So again, by the distributive property, the 2 multiplies the 3x, the 2 multiplies the 10. We wind up with what? 6x plus 20. Now we add the 5, leaving out the parentheses and the like, adding on the 5, the 20 plus the 5 give us 25. Now we're left with what? 6x plus 25. What's the last step we do? We multiply by 4. The 4 multiplies the 6x to give us 24x. The 4 multiplies the 25 to give 100. And therefore, all of these steps, once we write this using the rules of algebra, simply break down to what? 24x plus 100. Look how simple this looks compared with this. Look how simple this is. It's much easier to use this recipe. Look what this recipe says. Start with x, multiply by 24, and add 100. In other words, looking at something like this, let's call this program number 1. Input x, add 2, multiply by 3, add 4, multiply by 2, add 5, multiply by 4, and the output is y. Compare that with input x, multiply by 24, add 100, and the output is y. Do you see how compact this is? The more compact this is, the less chance there is you're going to make a careless mistake. Every time you're doing a step here, there's one more chance to make a mistake. Moreover, if you were going to compute the output for many, many inputs, in the long run, this would allow you to work much faster. Moreover, remember, the only difference between arithmetic and algebra is in arithmetic, you start with the input and find the output. With algebra, you start with the output and reconstruct the input. So suppose, for example, I want the output to be 196. See, I can go through all of these steps and reverse what I'm doing. In other words, to undo multiplying by 4, I'm going to divide by 4. To undo adding 5, I'm going to subtract 5. See, I can go through all these steps. And in fact, I'm going to do that in a minute algebraically. Or I could also have done the same problem by simply doing what? Undo adding 100 and undo multiplying by 24. So for example, suppose I picked 196 for the output. I say to you, solve this equation for x. Well, the whole point is that solving this equation for x is equivalent to solving this equation here for x. Now, how would you solve this equation here for x? Remember how the game is played. The x is protected by the parentheses, so we have to unblock the parentheses first. The 100 is blocking the parentheses. To undo adding 100, we're going to subtract 100. That wipes out the 100 here. It leaves me with 24x over here, and it leaves me with 96 over here. And knowing that 24x is 96, I simply undo multiplying by 24 by dividing by 24. Dividing by 24 on the left-hand side leaves me with x. Dividing by 24 on the right-hand side leaves me with 4. And sure enough, look how quickly I found the answer, but it's the answer to this problem. See, 4 plus 2 is 6. 6 times 3 is 18. 18 plus 4 is 22. 22 times 2 is 44. 44 plus 5 is 49, and 49 times 4 is 196. It actually works. Now, if we didn't see this shortcut, we still could have done the problem the long way. You see, all we have to say is what? We're trying to get at the x. What's protecting the x? It's inside the parentheses. The parentheses are inside the brackets. The brackets are inside the braces. So to get at this, we have to first do what? Attack all the different layers of protection. We first have to unblock the braces. The 4 is blocking the braces. It's multiplying. To undo multiplying by 4, we divide by 4. If we divide by 4 on one side, we also have to divide by 4 on the other side. That brings us down to this step over here. Now what happens? What happens next is that all this is one term, you see, because multiplication comes before addition. Don't worry about what's happening inside the brackets. That's all being considered to be one number. The brackets are being multiplied by 2, and we're adding 5. So the first step we're going to undo is what? Subtract 5. If you subtract the 5, that gets rid of the 5 on this side. 49 from 5 from 49 on this side leaves you with 44. So we're now down to this step over here. To unblock the brackets, since the 2 is blocking them and it's multiplying, we divide by 2. If we divide by 2 on one side, we also have to divide by 2 on the other side. And we keep on going like this. You see, we undo adding the 4 by subtracting the 4. We then undo multiplying by 3 by dividing by 3. We then undo adding 2 by subtracting 2. And what do we do when we're all done? We get back to exactly the same thing we did when we were solving the problem by replacing this by the easier expression. Okay? See the idea? In other words, look how much easier it was to simplify the expression and then solve. In other words, one of the roles of algebra is to reduce a complicated problem to an equivalent series of simpler problems. And sometimes it just makes things easier. Other times it's impossible if you don't do it that way first. See, let me show you another illustration. Let's see what we have over here. See, suppose I say to you, start with x, multiply, let me see if I can get this lined up properly. Does that look okay? Yep. Multiply by, input x, multiply by 2. Now watch this. Don't subtract 8, but subtract this from 8. Then whatever answer you get, subtract that from 50. Then add the input. And the question now is, if the output is 69, what was the input? See, something like that. But first of all, let's start with an easier problem. Just to get the feeling of this, let's see what would happen if the input was 3. You start with 3. This says what? Multiply by 2. That gives you 6. Now be careful here. This says subtract the 6 from 8. It doesn't say subtract 8 from 6. It says what? Subtract this from 8. 6 from 8 is 2. Now subtract the 2 from 50. That gives you 48. Now add the input. The input was 3, so 48 plus 3 is 51, so the output is 51. Look what would happen if you tried to reverse these steps. Since the output was 51, and you got that after you added the input, the first step should be what? To undo this, you want to subtract the input. The problem is you don't know what the input is. If you knew what the input was, you wouldn't be doing this problem. Well, rather than to bore ourselves by doing this problem all over again, because we know what the answer is, let's suppose we wanted the output to be 69. How could we tackle this problem? How do we subtract the input when we don't know what it is? We could certainly try trial and error, but a better way would be to use the rules of algebra. See, you input x, the first step is what? Multiply by 2. That would be called 2x. The next step says what? Subtract that from 8. That's 8 minus 2x, or by the rule of add the opposite, that's 8 plus negative 2x. The next step says take that and subtract that from 50. That's 50 minus, parentheses, 8 plus negative 2x. Now again, subtracting always means what? Add the opposite. And by the way, when there's no number present, you can always assume that it's a 1. Now what happens? To clear the parentheses, we multiply the 8 by negative 1 and the negative 2x by negative 1. Negative 1 times 8 is negative 8. Negative 1 times negative 2x, by our rule for sign numbers, is positive 2x. That says that this expression is now 50 plus negative 8 plus 2x. Well, 50 plus negative 8, by the associative property, we can add that by the rule of sign numbers. That's going to be 42 plus 2x, and we usually write the x term first. So this would be what? 42 plus 2x, or 2x plus 42. What was the next step? The next step said add the input. We add the input to this. That's 2x plus 42 plus x. X is the same as 1x. 2x plus 1x is 3x. We can change the order because addition has those properties. And therefore, this whole messy formula simply gets replaced by what? Pick a number, multiply by 3, and add 42. Well, that's kind of interesting. Pick a number, multiply by 3, and add 42. By the way, by the distributive property, notice that that can be written the same as start with x, add 14, and multiply by 3. Because you see, when the 3 multiplies the x, that gives me 3x. When the 3 multiplies the 14, that gives me the 42. So that's another way of writing this. Now watch the beauty and the excitement of algebra. I'm going to give you 3 separate programs. The first program says input x, multiply by 2, subtract from 8, subtract that answer from 50, add the input, and the output is y. The second program says start with x, multiply by 3, add 42, the output is y. Third program says start with x, add 14, multiply by 3, the output is y. Don't these 3 programs look completely different? And don't 2 of these programs look easier than the other? Don't programs 2 and 3 both look easier than program 1? But the amazing thing is what? These are 3 different programs that say exactly the same thing. For example, let's see what would happen here if we wanted to have the output be 69 over here. The output is 69. When did we get that? After we added the 42. So to undo that, we're going to subtract 42. That will give me 27. The next step was multiply by 3. So to undo that, we're going to divide by 3. That's going to give me 9, isn't it? Okay? That says if the input was 9, the output would be 69. Let's see if that's true. 9 times 3 is 27. 27 plus 42 is 69. Let's do it this way. The output was 69. You get that after you multiplied by 3. So to undo that, you're going to divide by 3. Now you get that after you added the 14. So to undo that, you're going to subtract the 14. That would give you 9, okay? Let's see what would happen. Now, if we see, in other words, the answer to both of these problems is 9. But if I hadn't made a mistake, this program is the same as these 2 programs. So 9 should also work over here. Let's try it. If I start with 9, I multiply by 2, that gives me 18. Okay? I subtract that from 8. Okay? 18 from 8 is not 10, it's negative 10. Now I'm going to subtract negative 10 from 60. To subtract negative 10 is the same as adding positive 10. That would give me 60 down here. See, 50 plus 10 is 60. And now what's the next step? Add the input. The input was 9. 60 plus 9 is 69. And notice what I've done. And I think this may be a good place to stop and to summarize today's lesson. You see, what happened is I started with a problem that was fairly complicated to keep track of. You see, the step subtracting from is much more complicated than the step that says simply subtract. So what did I do? By using the rules of arithmetic, I was able to paraphrase the statement I was looking at into one that was much easier to solve. This is the story of society. It's the story of civilization. We often solve well, let's not say solve, we often tackle advanced and complicated problems by reducing the complicated problem to a series of simpler but equivalent problems. It's not enough just to make them simpler, they have to be equivalent. In other words, if I make the problem simpler just by throwing out all the important stuff, what good is the answer? So what we basically do in the scientific method and in society, progress in general, is we do what? Take a problem that we can't solve, by critical thinking, reduce it to a series of one or more simpler problems, equivalent problems that we can solve, and then work from there. And you see, the only difference between arithmetic and algebra in that context is that through formulas, when you replace one of the quantities by its given value, the resulting equation that you get either has the variable that you're looking for all by itself on one side, or scrambled in with some of the numbers and the output being all by itself on one side. And in simplest terms, you see, if we think in terms of a computer where the recipe is the program, Arithmetic is when you have the input and the program and you want to find the output. Algebra is when you have the output and the program and you want to find the input. And in many cases we find what? That to simplify this problem, the rules of algebra allow us to replace more complicated expressions by simpler ones. And as we advance through our course and into subsequent courses, that's the only difference between beginning algebra and intermediate algebra and advanced algebra, is just how complicated the paraphrasing has to be. Next time, I'll show you a couple of real-life examples of how formulas are derived, and then try to explain to you how it might be nice to know that, but the beauty of algebra is what? Once you're given the relationship and you accept it, you don't have to know where it came from to be able to use it. But again, that's going to be our topic for next time, and so for now, just do what? Study hard, right? Keep learning, stay young. See you next time.